All right. Hello, everybody. Welcome to the June Rust Gamedev Meetup. If you are here, hopefully you are here for the Rust programming language. I know it's the same name as a game, and we're talking about game development, but we are here to talk about the programming language. And so, as always, we'll get started just with a few notes here. I want to hop right in, though, because we have a lot of speakers today, a lot of really great content. Let me know in chat what's been going on this month, what you've been up to. If I see stuff in chat, I'll make sure to mention it in between speakers. And so hopefully you can hear what kind of cool stuff people have been doing. For myself, I've been playing with Bevy and Naya of recent. So like Naya is like a networking library. And it's been pretty cool kind of exploring how it can really just like sit on top of the ECS in a lot of ways and just propagate stuff between players in a multiplayer lobby. And so I'm kind of exploring like an idea that's, I would say, like similar to something like maybe Jackbox games or maybe like Werewolf or something. I want to try and like make a game that can kind of work networked like this. Pretty nice and simple, but more just a test of how it goes. And also I think that there's like a massive amount of space that hasn't been explored within this like area of like couch co-op games that you can play on a phone or something. So that's what I've been sort of playing around with. Feel free to mention in chat and I will give people shout outs. Oh yeah, we got shout outs. If you mention on Twitch or YouTube or Discord, we will be more than happy to say what's been going on. And also just a reminder, as always, if you stick around after today's meetup, you can come and chat with the speakers in the Discord for the people, for the speakers that can stick around. I know some have some stuff they have to do afterwards. But anyways, I'm also going to do announcements right off the bat here. Normally I keep them till the end, but we got some stuff here at the beginning and I just want to try to cover it now. So first off, the big one, we got Rusty Jam #2 coming up. So let me go and open the page here on itch. And so with the Rusty Jam, this is just an opportunity to make a game in Rust, in any type of Rust, really. You could use an engine. You can do it just in bare Rust. I've been playing a little bit with Rust Godot, and so that's a pretty cool way to kind of interact with a game system. And then we got like Bevy, we got Firefox, we got lots of big engines to potentially work with. Theme will be announced right at the beginning. Okay, we got some modifiers here already. Nice. So what modifier we got? Like a pet. We got one called triangles. I think we're gonna work on like adding some more modifiers and descriptions here. Portable, I like this one. Make sure that your game runs on like every system. I mean, with most of the engine, that's pretty nice and easily. Now I want to mention one that I'm gonna propose as a modifier, and this is one that a friend of mine came up with recently. So Zester, he's one of the other core devs of Valoran. Has a lot of other Rust crates that are pretty nifty. But he proposed this, and I like this idea a lot. So the rule for this challenge is that your game state can take no more than 64 bits. And so between different frames of your game, you can't store more than 64 bits. So Zester, I think, made a game, Snake in 8 bytes. And I kind of want to explore it from, and I mean, this is like the most basic thing ever, but like a story game, like, like an adventure game sort of, or what do you call it? Not really choose your own, well, a little bit choose your own adventure. But I mean, that would be incredibly easy to store the states. But then Zester also mentioned, you can have like an inventory that takes up part of the state there. So I might play around with this one for the Rusty Gem. Also, newsletter is out. As always, gamedev.rs. We have, let me just make it look like normal. This month's newsletter is out. We got lots of really cool stuff going on. We're going to have Carlo here today to talk about how the arcade cabinet's been going. We got this pretty cool 3D Ferris. And another one of the announcements that I want to just mention here, the Rust Graphics Meetup 2 happened. And so if you want to see what what talks happened, we have them in a playlist on the Rust Game Development YouTube channel. 3 different talks. One's a 20-minute talk, one's like a 10-minute talk, and then Connor's for Ren 3 was like an hour-long talk. Great content. Love it. Super good. So without further ado, let's hop right into today's show and tell. We have Wait, sorry. I think I put at Carlo. I didn't put the full username. That's my bad. But we have four different topics today, and so we will be right back in just a minute with Quark to talk about Choir. All right. Hello, Quark. So I will hand it right over to you, and you can get right into talking to us about Choir.
Hello, everyone. I just wanted to tell you about a small project I've been doing for the last 3 months. It's called Choir, and it's a task orchestration framework. I'll try to explain those from the back. So it is a framework because it changes the way you organize the code. And that's not a side effect. This is the main purpose of this thing. Unlike most of the things that are just libraries that help you do what you want without changing the way you want it. Then orchestration is for planning and coordinating elements of execution of your program. So it's about organizing your control flow, basically on the macro level as opposed to micro level.
Sorry, I don't think we see your slides if you have slides right now.
You don't see my screen?
Oh, we see StreamYard, but we don't see if you have slides that are presenting right now.
You see my screen, but not what I see on my screen.
Presumably, I think.
Even now?
We still just see StreamYard here.
Interesting. Okay.
Maybe if you don't do full screen on the presentation. I'm not sure why. Yeah, StreamYard's not picking it up here.
Share screen. Okay, that may work. Let me try again.
All right, let me see. Yes. Perfect.
Aha!
There we go.
Technology wins. Okay. Sorry about the technical difficulties. And as for the task, is the unit of scheduling that we have. The basic idea is that you represent your program as a graph of tasks, and you feed those tasks, and Choir is responsible for scheduling and running them. This is not new. You might have seen the Destiny's 2015 talk, which this screenshot has been shown thousands of times. Sorry for bringing this up again, but it's just to set up your expectations on what is the world I want to see big applications doing in Rust. Why do you need that? You give out the macro control flow, and in exchange, you get free scaling at multiple levels. It is both for performance and complexity. Performance because you can flexibly control how many cores are used by your workloads without changing anything. So it separates scheduling from your logic, basically. And complexity-wise, because again, you don't think about how do I properly organize my code. You just split it into tasks and describe the tasks to the system, and it manages the complexity for you. And Benjamin had a good quote recently, but you've got to have something really good if you want to take control of the control flow of the user. So my hope is that Choir allows you to do that. Again, the basic idea is that everything is a task. The tasks are supposed to be somewhat medium to large size. So it's not like you're iterating an integer array and everything is a task. Only if you need to compute something for each integer, then it would make sense to be a task. It allows you to scale, as I mentioned, scale your code in terms of how you organize it. So it eases your burden on thinking about the code, separating the scheduling from the structure of the code. This is a rough example of how the API looks like. You create a Choir instance, you add some workers, and you add some tasks. You can say one task depends on another. That's pretty much it. The tasks are just closures. This is as simple as it could be, I believe. And here's a more real-life example of what those tasks can do. Say you're in the business of doing the asset pipeline, and you're loading a scene, a game scene, perhaps. And it involves a whole bunch of small, semi-independent tasks. First, you want to parse the scene and see what resources it references to. Maybe it references some meshes or textures, and you want to load those. And each of these loading processes can technically be independent, so you create tasks for them. You create some shader programs, maybe pre-processed shader modules. That's another CPU-intensive task. And then maybe you want to create your acceleration structures for the meshes, and the top-level acceleration structure needs to wait until all meshes are done creating their bottom-level acceleration structures. So you describe these dependencies, and finally, when you created this, maybe you want to populate the shader data with like the buffer addresses and everything like that. And that's another task. And after that, you are done. So the way you would organize this in Quire is that you would create this done task, which does nothing. It's a dummy task. And then you would create this tree of tasks. Some tasks may create tasks from within their own execution, like the parsing a scene is a task, and it will create more tasks and set up their dependencies and schedule them for execution. So this is what the tree is going to look like when you already parsed everything and you're waiting for it to complete. And then for the end user, like the user of the your engine API, all they need to get is the handle of this done task. And then they can schedule their own things depending on the scene being loaded. And then it's all going to scale to your multiple cores without any extra effort. What we see currently, and this is the problem that partially inspired me to solve it, is that Rust embraced entity component systems really hard. Like Rust discovered that it fits very well with the borrowing problem, and that you can describe the systems, and it provides a framework. Again, ECS provides a framework of thinking, and it encourages you to put all the data into the entities and in the components, and then schedule the systems that would process those components. And what concerns me is that Rust ecosystem tried to put everything into entity component systems, even things that don't quite fit there, like the spatial hierarchies, for example, in the scenes, or things that are unique. For this matter, in specs, there were introduced resources, something that is not a per entity, but just a global thing that you can lock for a system. I think the presence of the concept of the resource in an entity component system is a sign of failure. It's a sign of failure that we're not using the entity component systems correctly. We're trying to fit something that was not meant to entity component systems. So Quire is able to solve this without breaking your workflow. This is what I just described. Basically, an application with the entity component system, it interacts with the scheduler by registering systems, and then maybe it touches some other data. And this is complicated because the other data lives somewhere outside of the entity component system, and you need to figure out how to lock it if you need to access it, and so forth. And some of this data you would put into the resources of the entity component system. And with Quire, it may look like this. So the idea is you would still have the entities and components, and you may still have even systems, but scheduling of the systems would go through a layer that is accessible to the application itself. So application could register its own tasks to the Quire and schedule them, as well as entity component systems that would translate into one or more tasks. For example, if you're processing 1,000 of entities, maybe it makes sense to chunk it by like 10 hundreds, and each of them can be a separate task in the task graph. So in this model, anything else that an application wants to do would still go through the task orchestrator and would still be scheduled together with the entity component systems work. It's not going to be a separate thing. So it tries to unify the scheduling in your application. Choir is a toy project, of course. It's not something you can just take and it's going to work for you. Probably will not. But it has some nice things that I tried to put into it, like task dependencies, and you can file more tasks within executing other tasks, as I mentioned. You can depend on a task that is already running or finished running. It doesn't matter. You cannot add a dependency if you're already running, of course, because you're already running. And it supports some interesting things like multitask, where you can say, I want to execute a task for each index from 0 to 1,000. And then the closure that you are passing has this index of the task that it needs to execute. And this helps in a bunch of cases where you have arrays to process or multiple elements and you don't want to submit individual tasks for them. And finally, the icing on the cake is that you completely manage the workers. In all of the systems that I saw so far, when you create a task system, you give it the number of workers, and this is it. This is permanent. In Choir, it is flexible. You create the workers. As soon as you drop the worker, it finishes the work and disappears. So what this allows you to do is that if there is something heavy going on the computer, for example, you're on battery instead of the AC, or you notice that CPU is consumed by other processes, like the user is streaming something, you may reduce your number of workers accordingly so that you don't try to take possession of the whole CPU. Essentially, this allows you to get closer to an ideal situation where something like Choir is a part of the system. And actually, macOS has this. It's called the Grand Central Dispatch, also a task processor that is system-wide. I think it's a very cool idea. In terms of the internal organization, I would like to stress how cool Arc is. This is the sort of a lifetime of a task in Choir, and it's a neat trick to use Arc, I think. What we see here is that when you create a task, you basically put it into the Arc. And whenever you depend on it, whenever it depends on anything, that anything is a dependency here. On the blue color, it will hold an arc of the task. Once the dependency finishes executing, we check for what are the dependents, and we have this arc. And what we do is we try to unwrap it. This is the thing that's rarely used, I think, in Arc. But if you succeed in unwrapping it, this means that your arc is the last one. And for the task system, it means that the task that is a dependent can now be scheduled. And then after you unwrap it, it can go to the queue and be executed. So queue only works with the unwrapped tasks. And this is like nice packing of the arc to solve both lifetime problem of the task and the dependency problem of the task. Then task itself can have dependencies, and it holds them by arcs. And again, after the queue finishes executing the task, it will do the same thing. Like it will go through its T2 and T3 and try to unwrap them, assuming that maybe they're the last one. So Rust language is really helpful implementing this kind of thing. In terms of the overhead, again, there's probably a room to optimize, but what I see today is that a single task can take 60 to 280 nanoseconds, which is not much, assuming that I position it as for the macro level control flow organization. So it's not for very, very small tasks. You have to do some work in there. The multitask is the thing that I mentioned, where you say, I want a task to run from I of 0 to 1,000, for example. And in this case, 100,000 tasks. A lot of things I want to do with it. I want to be able to detect circular dependencies so that it doesn't hang, obviously. I want to hook up Loom. I've been trying to do this. It's a wonderful library for validating your multi-threaded code. I totally love it, and I'm trying to get it working and cooperating with the authors. Basically, passing Loom, in my eyes, is like formally verifying that your multi-threaded code is correct. And finally, I want to do that thing for Hex. Hex is a minimal ECS that doesn't have a scheduler. So I think it's in the best position to cooperate with Quire on actual scheduling of the tasks. And again, I want to work with the author to get this running. This is a bonus of sort of a map of control flow for everything that I was able to come up with. You can see on the left, there is a micro control flow. On the right, there is a macro control flow. So in Rust, when you do micro parallelization, you generally use fork join helpers. And Rayon is the most popular. I think Parasol is used now in WebRender. Is also interesting to look at if you're curious. And you can also do it manually with your own code, which is here as an imperative code. And aside from the imperative code, there is an async part. And this is a big, big part because Rust has the whole async infrastructure to allow you to control scheduling with help of the language. I think async is a fair way to go. And if you're going async, God bless you. I think it's just not for everybody. And I was trying to design it without async in mind at all. Also, async is not going to help you with things like the multitask that I mentioned. So in Quire, I'm able to do some things that async cannot do. And in the macro control flow world, there are task and job systems, basically. And I split them into two groups, but really they can be combined. One of the group is the resource that are ordering tasks based on the resource access. This is the classical thing for the entity component systems, where you say that system A depends on system B if they access the same resource and they cannot share this resource, right? So this is resource-based ordering. And the other group is the execution ordering. And this is where Quire is. You just say something has to be done after something else. And if there is a resource you're sharing, then this resource can use a lightweight sharing mechanism, which is just going to check if it's shared properly. Interestingly, it turns out Rust does not have this mechanism. For single-threaded, Rust have ref cells, like a lightweight mechanism for checking. But for multi-threaded, the standard library recommends mutices and RW locks, which are not lightweight. And they're not just checking, they're locking. So I actually have a primitive that I developed to help with that. This is lightweight, and it's called a syn cell that allows you to share things between tasks. I can talk about it separately. And that's pretty much it. Yep. Happy tasking. I hope somebody understands my paradigm and worldview and jumps on board to try it out.
Nice. This is super cool to hear. I think a few things that I'm wondering about. So I asked one question in chat here. So we talked about how task scheduling can work and be optimized for a single CPU. But I'm wondering, does Quire's paradigm and architecture, could it also be used on distributed systems? Say you have a cluster of 5 different servers that are running like an MMO game, and you want to pass like long-running tasks to other systems. Would it work for something like that?
That's a great question. I haven't considered that even. I think I'm going to focus on solving the CPU first. And then once this is done, maybe network is going to be next. It's also worth noting that it's inspired by something we heavily use at work. Much more complicated than this. But our work is in C++, so I had to do it.
Nice. Yes, nice. Yeah, it's always good to take like inspirations from the other stuff that you work on and kind of narrow it down to, just like pull out what kind of stuff can be used. Connor mentioned here, async is a really heavy hammer that is hard to get to use right, and learn this one from experience. And so, yeah, I definitely, it makes sense that there's a lot of stuff to kind of think about and consider there.
Yep.
I had one more question. I'm trying to remember what it is. We were talking about async and tasks and ECS, and I don't exactly remember what it is. So what I'll do, I'll put it in the chat later. I'll ask you on the Rust Gamedev Discord. But awesome, and thank you very much for this talk. I think it's yeah, pretty cool to kind of see some of these systems that we might be able to use for maybe thinking in a bit of a different way when we do some stuff with Rust game development.
Yeah, thank you for having me.
Absolutely. I hope to see you in the future. All right. Hello, Carlo. So it is now time to hear about how the Rustconf arcade cabinet is coming along. So tell us a bit about it.
Yeah, so first I'll give an introduction for those who might not have heard about this project yet. So this arcade cabinet right here behind me that I've been working on for the past couple months is going to be at Rustconf, the in-person conference in Portland. My plan is to load it with games made with the Rust language. So far I have 8 submissions, plus I plan on putting 2 of games I've worked on there, so 10 total. Definitely room for more, and I'll explain for you how to get your game on later in the talk. But this is just a chance for developers to show off their games to the broader Rust community and have them played in person at the conference. But yeah, I thought I'd just give an update on the cabinet. I'll show it off here. I'm just gonna put my headphones down so I won't be able to hear you, but this is the cabinet. I put the microphone here. Cabinet's built. I'll show it off here. So we have the screen and the buttons here. Here's a, make sure it's on here. Here's one side. It's got a little flap here. You can put the motherboard here, and this is where all the ports will come out. Got a fan and a speaker here. All right. So in frame. Here's the power supply. It's just this is just basically a PC. So you can open it up. And there's all the, sorry, the door's kind of blocking it, but you can see all the internals there. So there's the screen and speakers and power supply. I'm going to be installing the motherboard and stuff hopefully this weekend. So that's that. And there's the other side here. Nothing much, just some fans and stuff. But I'll just turn it back here. But yeah, so this is a real thing now. It's not just CAD anymore. It's definitely happening. I also wanted to share that I have commissioned some art, and I'll show that. I'm actually going to share my screen here. How do I do this? Oh,
I'll toss that up. Is this the one you want?
Yeah. Cool. Yeah. So, wait, no, that's. Oh wait, that's from the newsletter. Yeah, I was going to share my
yeah, go for it.
But yeah, I was going to show the same thing, but it's good. Share screen, select window or screen.
Yeah, when I saw this one in the newsletter, I'm like, oh my goodness, this is like such a cool decal on the side of it. Like it's so colorful and everything. So yeah, I was able to see the files of it.
Yeah, well, I can go a little closer in here, but yeah, this is Ferris. It's got a new look. There it is.
Awesome.
I was looking. The inspiration was those older video games where they have like your character in the game is like 12 pixels, and then it has some like a beautiful cover art for the game. And so I kind of shared that with like some of those kind of art with the artist and said, hey, can you do that with Ferris? And I showed him Ferris. It came up with this. So I got one for this side. I'm also going to get one. Currently, I've seen this sketch. There's going to be one for this side. And in the middle, since there's a lot of holes here, I'm probably just going to put some kind of like this background design here. And so there'll be art on all the visible sides. And yeah, so that's kind of basically I wasn't planning to do art earlier, but when I saw how surprisingly cheap these metal parts were to have made, I was like, okay, I've already kind of parted with this money anyway. I guess I'll spend it on something to make this project even cooler. So I decided to commission some art, and yeah, I love I love how it's going so far with that.
Yeah. Yeah, that's really cool. And I think as well, I'm really excited to see what the other side will look like. Because I imagine like seeing this in person, like when you see a pinball machine or something, it has like all the beautiful art on it. And that's what this is becoming. And so that's like super cool.
Yeah, I can't believe how amazing the art turned out. I love it. But I was gonna give a timeline here of what's going on. So obviously it's built, still not quite done yet. Gotta turn it on and get all the stuff, computer parts installed. But so I'm still currently reaching out to devs. So if you like this project and want to have your game on here, it's free. I'm not, anyone can get their game on. I have a Google form on my Twitter. If I minimize this, maybe you could, oh no, I didn't share. Here, let me change what I'm sharing. Share screen. And let's do. Well, let me just try screen one. Yes, that looks good. Okay. Is that there? There we go. Yeah, so this is my Twitter. I'm at Carlos Sapina, all spelled out here. And on my tweets, you can see me. I pitch, the project, and then followed by this Google form here. So it's a very simple form. You're not committing to anything. It's, if you don't have time to do this, turns out you don't have time. It's, it's no big deal. But just fill this out if you have any interest. Again, at my Twitter, Carlos Sapina. And then followed by all those, I always pitch my Patreon. Yeah, so I hope to have the cabinet up early next week. I hope to have this thing turning on and being able to start working on getting my games on. And once I kind of figure out that process, that's when I'll be reaching out to devs to get, explain how to get their games compatible. Yeah, and then after, hopefully in about a month, that's when I'll have to partially disassemble this and send it off to the vinyl sticker printing people and get those stickers applied. So really, this next month is kind of when I want to get most of the games that are going to be on there. So please, if you have any interest, fill out that Google form, and we'll get started on that. Do you have a? Yeah,
just one question. So also, I'm a part of your Discord server. Is that Discord server open to other people who want to help contribute?
Yes. I don't know. Yeah, if you have, well, maybe I'll just send the link in.
Yeah, I think if you send it in like the Rust Gamedev Discord, that would be pretty good, so people can join that. I imagine there's a discussion going on there. I
haven't made a post in the Gamedev Discord, so maybe I'll make a big post after that and hopefully get some more submissions and share how to get involved, because I imagine there's more people there that might want to get more involved with the project. Anyway, but yeah, so that Google form, get your game on. Follow me on Twitter, obviously, for more updates. And then I also created a GitHub organization for this. It's just called github.com/rust-arcade. And right now, all that's on there is the CAD. And so I want, the design, well, it doesn't really help, but I want the design to be open source. So if you have, if you want to fork it and make your own cabinet or modify it, I think that'd be awesome. So it's all going to be on there. And then I also plan on, when we start working on the launcher and any other kind of hardware interface, like getting the lights working, we'll need to write some code for that. And that'll all be in this organization. So if you want to get involved with that, github.com/rust-arcade. And obviously, if there's any other way you can reach out that I'm not, you can always just DM me on Twitter or on Discord. I'm in all the Rust Discord servers. And yeah, I guess the last thing I want to make sure is, if you want to support the project, I'm on Patreon. It's patreon.com/metalmancy, like this. And you can donate to support the project. I have one very generous patron who, Michael Ramirez, who decided to be my first patron. I'm super grateful for him. It's really helping me support the project. So yeah, that's the project. I hope to see more people do submissions, and yeah, hopefully this will all go smoothly.
Good stuff. Yeah, and I think one other thing I'm sort of curious about on the progress side. So we have the physical side working pretty well, and you're going to be working on like getting the games on with some launcher. We've also talked a bit in the past about having like the lights on it, and so I'm curious, like with these like 3 different paths of like the physical part, the lights, and the launcher. Like what are so on each front? What could contributors come in and help with?
Yeah, so the physical side, obviously it's hard for you to do anything, but what you can do, and I am very open to, is suggestions. So if you have like, wow, it'd be really cool, maybe I didn't consider like this type of input that a lot of games might have. You know, you can swap out these panels very easily. There's just 4 screws, and we can install a new panel, so we can swap those out during the conferences. So if you have a game that maybe has some unique input that I'm not considering, make sure to tell me. Don't be scared to, you know, not bring that up if you want to submit a game like that. We can figure out a way. So that's one way, is just suggestions, and, you know, accessibility too. If I'm not considering something, you know, let me know. That's physical. And then there's kind of in between, which combines physical and software. It's sort of things like the lights. Again, it's going to be a little bit hard if you don't have the hardware, but these are just LEDs. You could, you know, get the same hardware. You know, it's not that complicated. It's just turning on and off LEDs. So especially in the bridge between kind of the hardware running on the microcontroller to going into the game. So like some kind of serial reading or some kind of protocol for bringing that data into the game. I think that's something that's probably people smarter than me that could definitely contribute to. I have ideas of doing it, but I haven't really started on that yet. The other way in software, the launcher, I don't have anything so far. So if anyone wants to get started with that, please feel free. I know we've talked about using the Valorant launcher in the past, but those are all, you know, the lights and the launcher, those, you know, that's not what I'm focusing on right now, because those
are like a little more open-ended.
Yeah, it's a little bit. We'll have games running on it as long as I can get this working. All that is extra sauce, which would be amazing too. And but if that's stuff that I'm not focused on, is the point. So if someone else wants to get involved and start kind of taking initiative on that, I'd be super grateful for that. And of course.
Perfect. Awesome. Well, if you can make the post later today about how people could get involved on like the Rust Gamedev Discord, that'd be great. And I think we can see a lot coming together right here. And this is like the final stretch, right? I think you said at the end of June, this is where you're locking it in, right?
Yeah, well, actually I've sort of switched on. So after I figure out the process for getting games on, my next big hurdle that I have to do is how am I going to get this there? So I'm probably going to be getting a big Pelican case and kind of working on packing, because I want it to I want to be bringing this all over the place, you know, wherever Rust conferences might be. So I want to get some good packaging, which is another big expense. So I'm going to be kind of working on that and probably getting foam inserts made. But I forgot what I was saying. That's sort of where I'm going to be after I kind of figure out the process, and hopefully just get others going with that, and hopefully people in the community can help each other. And of course, I'll be able to help wherever I can. And yeah, that's sort of the timeline so far.
Awesome. Well, good stuff. Thank you very much, Carlo, for showing this off. And then I hope you can see where it is next month, because it's getting close, and we'll love to see how the progress is going. So we'll see you next time.
Sounds good. Thank you for having me.
Cheers. There we go. Hello, Tog. I don't think I see your camera on right now, but what will you be talking to us? I think retime, right?
Yeah, right. So hello, everybody. Can you hear me?
Yes.
Good. So let me share my screen. This one. Nope. All right. I think now the screen should, yeah,
Perfect,
you can see
yes.
my screen now, right? Okay, yeah. So I'm going to talk about this project called Retime. And just today I realized that the last time I was presenting it, it was called Time Loop. So that's maybe where the confusion was coming from. So the name is changed just because Time Loop is kind of boring and Retime is, I think, is better. Anyway, this is a small game, a demo for Dotrix, for those who doesn't remember it from the last time or who didn't hear about it. Yeah, so just a small recap. This game is basically a simple puzzle-like game. The goal is to reach, I'll probably start playing some level just to show you. So your goal is to reach some target position. You can see that those small flag at the end. And what you can do, that you can revert the time back. So, and now we added a couple of new objects. I'll talk about it later, but I just want to show it quickly first. So what I did now, I activated this trampoline that should help you to jump over the wall. I think it's pretty similar to how it was before. And so, yeah, I was you could notice that the ball was going backwards. So that was, I was reverting the time. When you press the space, the time is reverted. So it's as simple as that so far. So what's new in what I showed, that the UI, you could notice it, that now we have on the right top screen, we have this kind of clock thing. Before it was a progress bar, which was quite confusing for many people. So that's why it's changed to the clock. Now we also have the main menu where you can select different levels. And this was a big thing. Like now these levels are not hard coded in the game. You can define your own level in a simple YAML file. I'll show it here. So the levels look like this. It's pretty straightforward. You specify the model for the level, the target position where the player should, the position the player should reach, and then you specify the objects. And then there will be a parser that's able to figure out what's the player, what's the time capsule, what's the trampoline. What's next? Yeah, also the asset loading process is now much better. The way it works, then when the game starts and you select the level, there is this very, you could notice the loading screen. So during this process, the assets needed for this specific level are loaded. And then when you change the level, for example, I go back to menu, I load another level, the game will only load the assets that were not loaded before. And since it's expected that later there will be much more assets and these maps are quite heavy, it's not good to load them all at once. So you'll be loading them as needed. So new objects were added. Now we have this time capsule or whatever you call it. It's kind of hourglasses. So when you collect them, you can rewind more. And this thing on the right top corner, it's filling with green color. So that's how much you can rewind. So if I press space, now the time goes backwards. And once it reaches the limit, that's basically how much you can do that. And if I release the space, it replays all the actions, and those actions can be overridden. So it goes like this. What else? Yeah, now there is a quick README as well available. So here, the basic controls are described. It's still a bit cumbersome because the focus was on the core of the game. And now I'll basically focus on making this game fun to play or more interesting to play. I know we could design new levels, new objects, different types of objects, and basically to finally start making interesting levels that are not that trivial to go through. And I think that's kind of it. Oh yeah, maybe another thing. I mentioned it last time. It's still an issue that there is a single thread where the physics is simulated and also for the whole game itself. So there is an idea to introduce a dedicated thread for the physics simulations. So this way there will be no dependency on FPS and so on. So yeah, that's it. It was a quick update. We also got the Discord channel on official.trix server, so I can later share the links to the channel and GitHub if anyone is interested. Yeah, thank you very much.
Great. I have a few questions I'm sort of wondering. So this is more on the design side, but with a game like this, one of the main mechanics that I see is as you rewind time, you retain your velocity, right? Like if I'm falling and I rewind time, then I still get that same velocity when I'm done rewinding.
Yeah.
Okay, so in that case, this sort of reminds me of games where you have to get really used to some mechanic that will not be intuitive to how you normally play games. And so it reminds me of something like, and not exactly, but there's like it's like 4D chess, or something like that. I don't remember exactly what it was, but it had these really weird rules that since you put it through time, you could like do interesting like knight moves through time and do stuff. So that's one. And then another one, there's like this other 4D shape game where you can move shapes through the fourth dimension, and it really messes with how we think about moving stuff around. And so, have you thought about the puzzles that you'll get the players to do in the first few levels so that they can become more familiar with this, and then like in planning out a level, like or when they go to play further levels, they have like this intuition on how they can sort of approach it?
Yeah, absolutely. That's actually a very good point, and I think that's exactly what would be the next step, to focus on designing those levels that would be intuitive, like very simple ones, so the player can just understand what it actually means to rewind the time, how it works. Because in reality, when you replay it, it's actually simulated, and you can sometimes override the actions. And if you do, for example, the thing is this trump line, it kind of rewinds the action of the ball, but it doesn't mean the ball will follow the same trajectory, because when you throw it with the trump line, you basically change the history. So this kind of stuff, that's why I'm saying that the control side a bit cumbersome. So definitely I will try to make it more intuitive, design some levels to explain how to actually play it. And after that, you can have real interesting levels, like which are harder to pass. And of course, like now it's very simple, like this trump line and these hourglasses, like more different types of objects would be interesting. I know some destructible stuff, some moving stuff, all sorts of things. So like it's really like when the core is sort of there, I mean, you can play it somehow. Now it will be all around what I've just mentioned.
Okay, interesting. And I think on the other side of, so that was like the complexity of the design, the complexity of mechanics that you have to teach. But then on the other hand, it also reminds me a lot of a game like Golf with Your Friends, in which you have to sort of get your ball to somewhere else in the map, and it's just like mini golf type of thing. But I could see this being incredibly fun. Not that it's like that if you're thinking it's a multiplayer game or anything like that, but if you have a game like this where it's like weird physics and stuff going on, and you're playing this with your friends and you have some objectives to do, there could be a lot of really cool multiplayer interactions here as well. So have you considered that at all?
Well, I thought about it, but then, this will probably, I wouldn't focus on it in the beginning, just because
Yes.
it will be so complex to make it over the network.
Yep.
Like, I don't want to introduce any sort of, how you call it, when you have, I don't know, some time. So you did some actions, then you need to wait until everyone finishes, because otherwise you will just mess up with this rewinding. I mean, if everyone starts rewinding at different times, so I didn't quite get how to manage it. So that's why I thought, okay, let's make a single player game first, because the original idea was just to have a demo for .trix. But if at some point, why not? I mean, I was definitely thinking about it, but I just didn't get it in my head so far.
Yeah, and I mean, in asking that question, I didn't really remember the part that like you're also going through time, and that's like incredibly complex to find some way to do it when you're playing with other players. But at the same time, if you did figure that out, that would be like a really, really different game than anything that I've ever played before. And so,
like there was an attempt to come up with something not like super unique, but at least something new. Like it wouldn't be like all the other games, and I agree with you that figuring out something like this would be super cool. But yeah, it's probably something to think about again.
Yeah, perfect. All right, well, Tog, thank you very much for showing off Retime, and I hope that we see it again in the future. It's really cool kind of seeing the progression on this. So thank you very much.
Thank you. Bye.
All right. Hello. So we are back with Graphite, and we've got the whole crew here today. We see we've got the people with Graphite shirts now multiplied by 3. I didn't actually see True Doctor had it. So everybody has the shirt now. This is very cool. So I will hand it over to you and tell us what you've been up to.
Okay, yes. I'm Kevin, the project creator. This is Oliver, the sort of co-founder.
Yeah.
And then on the other camera, visiting you from Germany, we have Dennis, or also known as True Doctor. So let's get a status update on this month's work of Graphite.
Hey, so let's see. So for anyone who's not familiar with Graphite already, Graphite is sort of a versatile kind of 2D counterpart to Blender, as you can see. Our goal is to provide amazing vector tooling and raster tooling to anyone out there who needs it, just like the 3D community needs a Blender. We kind of allow, layers similar to Substance Designer, Krita, Photoshop, and GIMP, as you can see. An overview. We're really focused on non-destructive and procedural workflows, similar to Houdini, and we have a technology that we've begun to develop known as graphene, and we're going to be talking a little bit more. Dennis will be a little bit near the end on some of the node-specific work that's been done this sprint, and some future thoughts and continued research.
Yeah. So, and also just a quick screenshot of a future mock-up. This will be what it looks like when we have the full editing capabilities. And this is the node graph equivalent. So the layer tree panel on the right and the document actual node graph in the middle. Both of those are an equivalent way of making it so you can work with layers, but also work with nodes when each of those is advantageous. So a quick update on the Sprint 15 progress. This past month has been Sprint 15. We created radial gradients, so I'm going to show off probably the new features, just the first 4 at the top near the end, or I could show it off after this. So we have radial gradients. We also have now keyboard-based accessibility to navigate inputs, so you can use the tab key and the up and down arrows, and you can navigate through each of the different menus, so that way you don't have to have a mouse. You can actually have the convenience of arrows and tab keys. We also have a font selector, so now you can actually preview all the different fonts. Instead of having to look up the font ahead of time, you can just see what it looks like in that menu. And we also have now for the performance, culling of layers that are not on screen. And then we also basically dedicated this entire sprint towards a bunch of refactors and cleanup and documentation and bug fixes. So in this time that we've worked on it, we've improved the way that the editor initialization flow works, and also the way that it loads fonts at the beginning when you load the page. We've also moved the front-end code to the Rust backend, so we're basically phasing out as much of the front-end as we can, just using the bare minimum, and moving as much as we can to Rust. That's going to be important because we might be switching over to a different front-end framework instead of Vue, possibly Svelte, or maybe even the Rust-based Dioxys. We do have to do a little more research on that, but we're looking to do sort of an interim conversion pretty soon. Also, we reorganized the way that the front-end file structure works and added documentation to each of the different parts of the file structure, so that's a nice way to basically improve the communication for developers and make it more friendly for new users for new developers to join. And then also we have a fixed implementation of the floating menus. So this is like the app bar, the file, edit, view menu. All of those different menus at the top bar. They were very, very fragile before, and it was super easy to accidentally cause an infinite loop that would force the entire thing to just never even load the web page. So never loading the application was not good. So we did a refactor of how that was implemented, and it's much more robust and much simpler now. And then also we worked on, during this time, 10 other bug fixes, including 2 crashes, and then even some more bug fixes that aren't listed here because they're even more minor. But this was basically dedicated to a lot of cleanup and refactors and bug fixes this month. So I'm going to quickly do a demo of this. So I can start out with the font menu. So we can actually see here, we have all these fonts. They load in as you scroll. So I'm going to scroll up to a random spot, and then we quickly load in all these fonts from Google Fonts. So now I can pick a random one, and we get this. Now we can also go over to this font selection, change the font to something like that. Maybe we could also change the different style. Oh, we have a lot of styles with this one. We can do bold and italic, or we can do thin. This one looks extra fancy. So this is also a good opportunity to show how the viewport culling works. So I'm going to go to the edit tool now, or the path tool, and we can see it's pretty laggy. We definitely have some room to improve with the performance, but we are now, as I zoom in, we're processing fewer of these blue overlay points. So now it's reasonably performant. But when I zoom back out, it gets kind of bad. So we are culling everything that is not actually having to be drawn now. And then when I move this off screen entirely, and just work with some simple shapes, we don't have to draw that entire thing at all. So in fact, if we go and look at the SVG for this, and if I move it off screen, we still have the SVG. And now that I move it off screen, it is completely gone. So that is a really important thing for performance. We also have radial gradients. So I'm going to apply a radial gradient to this text here. So I'm going to go to the gradient tool, and let's go from red to blue. Oops. And this is a linear gradient, but I can now change it over to radial. And I guess it's hard to see because here. I'll switch to radial, and now you can see the blue is coming from the middle. Also, I can do it over here and draw it like that. It's easier to see on this one. And then I can change the colors and all that fancy stuff. And then also keyboard-based navigation. So if I'm here, now I can use the tab key. So I'm here, let's say I have the file menu. So I can now use the tab key and then use the arrow keys to go, and let's say I want to close all. And this also no longer crashes the editor. We had a bug that crashed it. Oh wait, we still crashed the editor. Well, that's strange. We must have had a regression. A regression on our fix. But yes, so that's keyboard navigation. It's also especially helpful with, for example, changing the blend mode. So I don't know if I want normal. Let me set up some colors. So I'm going to change the blend mode now. And the question is, I don't know if I want normal or multiply or darken or color burn. Basically, I can just hit the arrow key and keep switching through them. And this makes it much easier instead of having to go through and click each individual one like we had to do before. So that's another fancy reason that it's not just about accessibility, it's also about user experience. Okay, now we can move on to some updates on node graph research from SureDoctor, also known as Dennis.
Right. So you can see the first node is just for nodes.
Oh, I'll just mention you're a bit quiet right now.
I can try to turn up my gain. Is that?
Yeah, that's perfect.
Right. Right. So I started experimenting with making the nodes async. So you have them have an async trait and basically make our whole node graph execution workflow as an asynchronous function. And that way we don't have to do the scheduling ourselves, and we can just use an async runtime to schedule the tasks. But the graph will always have regular sync nodes and the async nodes, and we can just groups of sync nodes together and integrate them into the async code flow. But having asynchronous nodes is also very important, because I've been working on trying to get GPU execution of code running. And GPU code will always be executed asynchronously. So we have to, because we want to implement or integrate GPU execution into our regular code workflow, we need to be able to execute the GPU code asynchronously during the evaluation of our node graph. I've made some progress on that. I turned our node graph description into Rust GPU code, which is, for those who don't know, Rust GPU is a project from Embark to directly compile Rust code to SPIR-V code, which we can then run using WGPU. This works by, well, how this will look in the node graph, at least for now, is that we have essentially a node, and I will give you some visuals on that in one of the next presentations, just didn't have the time right now. But we have a node that takes data as input, and it also takes a bunch of nodes as input. So it takes two inputs, data and a node graph, and then it applies, it's an array of data, it applies instances of that node graph to every piece of data in that array, and then outputs the result. We still have to figure out how to abstract over GPU acceleration structures. For example, GPUs have local memory, so we need a way to have an abstract representation of that. For example, we could define local memory and then provide the local memory as an argument to the node, like a resource to the node that the node can use during execution. And we'll have to think about how to make that user-friendly. Also, I'll try to close the window because there's a dog barking. Sorry about that. And we will need to build a framework basically to, at runtime, compile user code and basically execute the GPU code and compile the GPU code. But one potential avenue is that we could only compile the essential functions and not compile everything into one GPU shader, but rather only compile our nodes and then use Naga to link them at runtime, which is a lot faster than using Rust-C. Then we also wouldn't need to bundle Rust-C unless we want to support user code. So in most circumstances, that's a lot more lightweight and faster to do. Right, I think that's about it for the updates, and I'll try to keep you updated when I make more progress.
Okay, I'm assuming I'm unmuted, or I'm re-unmuted. So I think that's the end for us today. If you'd like to get involved, we have had a number of new contributors, so if you also want to be among those new contributors, please join us. You can also just try it out regardless of whether you want to add code or not. You can go to editor.graphite.rs to play around in your browser. It just takes half a second to open the editor. And then you can also visit us on the website, graphite.rs. You can also join us on Discord, which is discord.graphite.rs. And then you can visit our GitHub and pick up a beginner-friendly issue if you're interested. There's a lot of just interesting little bug fixes and small features that are beginner-friendly. We've been working on adding some beginner-friendly tags to the different issues that would be good for people to pick up at first glance. So with that, we will see you next month.
Perfect. Thank you so much. I have one question in chat, in the Discord chat. Is Graphite going to have a constraint engine like Autodesk Inventor or Fusion 360 Sketch Mode?
That is definitely something that we're hoping that we can do. I will have to do some more research on how that works, but constraints would be very useful, especially for a node-based editor. So that is tentatively the plan, but we do need to do a bit more design on that aspect.
Awesome, good stuff. Well, thank you very much for the Graphite updates as always. And I mean, every time that we hear Dennis talk about something nice and complex about architecture, I hope for a blog post to come out afterwards. And so hopefully we can see some more content from y'all on that?
Yes, we do have a blog now. Please check that out on the website. And we've been adding content every month or two. So hopefully we can get that cadence up and have more blog posts published on a regular basis.
Awesome,
I
good
should
stuff.
probably
Well,
try to start writing some of those.
it's really good to see, just like different people writing different stuff about what they're working on. So would love to see
Yeah.
it. So thank you very much. And also, Kevin, I hear that today you are graduating from your master's program. So congratulations from that as well.
Yes, that is true. I actually did finish my thesis on something related to graphite. It is actually. Do we have 3 minutes? I could very
Yeah, go
quickly
for it.
show it.
We're pretty good on time.
Okay. So let me open up. I have to run the code. 1 second.
We love live demos.
It's worth
Very
the wait.
It is worth
Yes.
the wait, yes. I think we are live. Okay. I think we're loading. There we are.
Wow. Okay.
Oh, sorry, I reloaded the page again by accident. So this is not Graphite. This is its own little web app. This is all written in WebGL, but it's sort of a prototype for the node-based brush definition in the future. So I'm actually going to open up one of the demo files. So this is sort of like a roller brush, like a dot stipple roller. Basically, the way that this is working is we are taking the input of pressure. Actually, I'll get to that part near the end. We're starting out with a Voronoi noise, and we're starting out with a pretty low jitter value. Actually, sorry, there's a bug that the numbers are not loading, but we are on strip. We are on, I forgot which of these we're on. Whoops, sorry, I have to reload that. But basically, we have that relatively grid-aligned but slightly jittered dot pattern. Then we feed that into a transform, which applies a skew. Then
Wow.
Also we're taking a Perlin noise of a certain scale, multiplying it by a larger Perlin noise, and we get more of like a sort of a slightly higher octave Perlin noise. Then we're blending those together with, I don't know which blend mode because it's not loading, unfortunately, the preset. And we end up with like a slightly less regular, slightly more like cloudy version of the original dotted pattern. Then we're applying levels to basically threshold it and cut off the light values and the dark values and clamp it down to this range where we just have these dots. Then we feed that into the blend node, and the blend node is multiplying this by the brush pressure. So as we can see over here, here is a 2D / 3D mesh of the basically a recorded brush stroke. So I drew this with my pen tablet, and it recorded in addition to the position of it, and then I took that X and Y values in Blender and made a mesh out of it, and it's loaded in here, and we wrapped the UV of this texture. But basically we also recorded the pressure, the altitude, and basically then this value here is the percentage, which is encoded as grayscale, that the brush is aligned with its direction of travel. So if you are tilting the brush 90 degrees away, then it's going to be, I think, black or white, and then it'll be grayscale if it's tilted in the direction of travel.
You could try feeding that in there.
But basically we have pressure, so we want to basically increase the pressure. Actually, we first want to invert it, so that's why we're inverting it here. We start out with the black parts becoming white and the white parts becoming black. Then we feed that into the blend node, and I think this is using multiply. And basically, we make it so that the parts that have less pressure are not as hard. Then we are just changing the levels to give it a little bit more of a kick, and then that is our output. So that is a way to create a kind of a stippled brush, or like a stippled roller brush. Another demo here.
So one way to, or what would you title this? Like a procedural, or like a node-based procedural way to generate brushes, or?
Yeah. So basically, the normal way that you generate brushes is either the way that it's typically done in vector software, like Illustrator and Affinity Designer, is that they actually draw a physical, like you can see we're generating this straight texture, but they actually do it in real life. They draw with a real brush of some sort, then they scan that and then mask it out, apply levels or whatever that's needed, just so they have that grayscale mask, and they use that as the brush style that's typically used in vector software. But the goal here is to generate that on the fly. And the advantage is that then you can generate the correct length, because otherwise you have to kind of just stretch the length when it's drawn on paper and scanned. So that's one advantage. And then in Photoshop and GIMP and Krita and pretty much all the other raster-based software, they use that stamping approach, where basically you have like a square or a circle texture that gets stamped as you draw a bunch of times. And the disadvantage of that is that you basically have this like really, really similar looking brush stamp that gets repeated over and over and over, and it starts kind of blending with itself and doesn't look very good. And this just provides more flexibility. So basically, Substance Designer has shown that you can basically make any game material for any procedural material for a game or any other 3D scene with pretty much lifelike photorealistic appearance. So why can't we do the same thing for the way that we generate brushes? We can basically make something that looks photorealistic. So here's an example of starting out again with this this pattern of Voronoi noise, and we're actually just multiplying the x by 0, or scaling the x by 0, where we just make it a streak. Then we blend in a little bit of the pressure input, blend in a little bit of the noise, apply levels so it becomes lighter, and then levels again so it becomes darker, and that ends up, and then also a gradient. This gradient basically is black everywhere except the very top and very bottom that is a little bit white, so it sort of gives a little bit of a fall off in the in that axis. And then finally we have our output.
Can you change the fallout for us, just because it's cool to see it change?
Yeah, so I can change the fall off. So
wow.
basically I'm just increasing that the softness of that edge now.
Mm-hmm.
Yeah, so you could imagine this changing when you're tilting your brush, or
Yeah.
So it's dynamic.
Like in the future, if this was even more sophisticated, we can make it so that fall off value is actually fed by your altitude or your tilt or anything like that. Because you can basically just drive those parameters into here. And the idea is that you can do this in real time, rather than, this is a recorded one just for this prototype, but once it's actually implemented in Graphite, you'll be able to do this in real time and see it generate the texture as you draw.
Yeah.
You can also do some even more photorealistic looking brushes. So I'm really happy with this one. This one looks really photorealistic in my opinion. So I'll just show the result first. This is basically an ink brush with like a diluted ink which has been watered down. And this models the way that in real life you have sort of a very crisp edge where the edge of the water puddle has been, and it sort of deposits a lot of ink along that edge. And then closer to the interior where it's still wet and it hasn't deposited that ink onto the surface of the paper, it sort of flows around and looks a little bit wavy. So the way that this one works, and I'll try and be relatively quick about it, we're basically combining these together, you end up with this thing, and you end up basically taking a larger and a smaller version, subtracting them from each other, and you end up with this thing. And you invert it and you end up with this basically. So this is how we do that outer bubble. And what we're seeing here is we're seeing a square texture where we're then going to take slices, vertical slices. So basically we're taking each column of pixels from this node, and that's based on pressure. So before we do that, we're blending it again with this one. So we end up with this thing, and you can see this kind of looks like the pattern of the result, but it's not stretched out. So now we're taking this node called a slicer, and what it does is it takes this texture and it indexes the x coordinate, which means the columns, based on the pressure value. So we're taking the pressure, and depending if it's black or white, that means that it corresponds to a column further to the right. So we start out with black, meaning all the way to the left, and white, meaning all the way to the right. And we're basically slicing out these columns and then converting it to this stretched out one. And that's what gives you this taper, because we intentionally designed this taper to have this sort of C shape to it, which means that as you increase pressure, and you have full control over this. For example, we could take the shadows and turn this to like 1.5, or let's say 1, and now we have a crisper edge like this, and now you can see it's much more crisp. Maybe make it a little bit softer, so you can see now we've made it a bit softer, but having less of that crisp edge.
What if we make it like 4?
Or yeah, you can make it really crazy and have a much softer, and this looks like you're kind of bleeding with the ink is bleeding over the paper more.
This is gonna be really cool to see in Graphite.
Yeah, so basically this gives the main advantage here is that you're able to give full artistic control to the artist to actually modify their brushes, which is not something you can normally do in other painting software. Typically you have to download brush packs, which are made by people who have an expertise in building brushes, but it's not very easy to customize really extensively. And here's the last demo. You can sort of just look at this one. It's relatively simple, kind of complex actually, but we're basically taking this sort of weird taper shape and then slicing it up based upon pressure, and then blending in a bunch of noise at different levels. And this is sort of just generally trying to look like a really solid ink brush, like using a really, really black ink with a really kind of sloppy, hairy paintbrush that leaves behind a lot of sort of roughness on the edges, but is otherwise pretty dark. And yeah.
Now, just as like a sort of an application question. Let's say I'm an artist and so I'm trying to mimic. You described how would you describe this one? This is like a really dark ink or paint?
Yeah. So this one was intentionally going after a really black ink. Like I've got a brush pen.
Yeah.
I've got a brush pen that's really, really black. So this here. Can I get it to focus here? I'm just going to put it on my forehead since it's focused on my forehead.
Yeah, it sounds good.
And then this draws on a piece of paper. If we have a piece of paper. So now we can see this is a really, really black line, and it's kind of like that.
Okay, so I can see an artist doing, so they're using this utensil to draw with, and so let's say they make like an entire drawing or something like that. Then what would the workflow look like of, okay, they finish what they want for the drawing, and then they want to go back and change the stroke and everything. Like, I guess they can like make 5 different versions as if it was like a watercolor or ink or harsh pen or something like that. Have you thought about this?
Exactly. So you can do an entire illustration and then go back and change the brush style, either the definition, so it globally changes for all the existing ones, or you can take the drawing you did and then just change the brush style to a different preset, and then for all those, all the layers that you drew on, each of those brush strokes end up being the new style. So of course it'll probably take a few seconds to recompute and re-render all of that for you, but hopefully we can get the performance down to be relatively real time.
Mm-hmm. Yes, that would be very cool. I would
that's
really
something you just can't do in other painting software. You definitely can't.
Yeah.
Just totally change your fundamental style after you've drawn the artwork.
Yeah.
Which gives you a lot of experimentation. Like maybe this might look better as a watercolor or a painterly or an acrylic paint style. You can just sort of play around with it and see what looks best.
I wanted to diffuse more, but it isn't. So let me turn up diffusion.
Yeah.
Like that's a crazy concept for paint.
And I think that's also a concept that you assume in academia. Like people will do research on image processing so that they can apply a filter to some image or something like that. But this takes the academia and brings it right to the people who are using it in the application itself. And like you can be the researcher who wants to try this cool stuff.
Yes,
also,
that's the goal.
To the point of experimentation, we also did some experimentation this was a while ago, but we also tried to work with the different materials and figure out how they work. And kind of have
so like breaking it down,
research going to turn that into a digital copy.
Yeah, wow, that's really cool. Because I guess like it's almost like you get some result and you're like, okay, what nodes would I put together to make this outcome, sort of, and you have to like break that down and kind of figure that out.
Yeah. It's also great if we have these, like, if you know this is how acrylic paint looks, and you have a brush pack available basically, and you can look into it, and then it's a lot easier to get started if you already know how something else works, and then modify starting from. It's kind of all this whole open source feeling and idea behind it that we can also apply to our asset generation, and that will in turn help the whole ecosystem if more people can contribute to like our asset collection.
Yeah, absolutely. Like, yeah, I really like that idea of someone made these like brushes and stuff, and you can just import them and use them. But there's, I mean, it's just a few extra nodes that need to be added, so it's like super easy, almost like as if it was a mod for it, rather than like an entire big asset pack or something like that.
Mm-hmm. And basically, this sort of brings the process of creating brushes to way more people than it is traditional in other software, which means that people create more brushes, they share them online. We might be able to make like sort of a default pack based upon the community's contributions, and just sort of make it so people have thousands of brushes to choose from, because there's really no reason that people can't share what they create, and make it so artists have control over choosing from thousands of options that really best suit their style. And I was actually thinking, was walking by the other day and noticed, hey, there's a contrail from an airplane flying over. What if you were trying to draw a contrail in an artwork? You could make a brush style that looks not like a piece of ink interacting with a piece of paper, but looks like a contrail interacting with the sky. And you could make a brush that looks like that. Mm-hmm, so exactly. It basically gives you the room to make things that aren't even really related to painting at all.
Exactly, because when we think of brushes, we only think of it in the context of like how art has been done conventionally for thousands of years, and so yeah, you can really start exploring. And I guess on that topic, then can you start exploring what stuff looks like in 3D as well through this method?
So one idea is that we do have a displacement output. So I can actually feed this in, I'm just going to start out with a new one real quick. But you can feed in displacement, and this is nothing revolutionary. You've seen this in plenty of other software. But you can feed Berlin noise and Voronoi noise blended together. And then feed this in as displacement. That is supposed to open a thing that shows the displacement. That's interesting. That must be a bug that I introduced in the last commit.
Oh, good.
Maybe give it color as well.
Yes. Sorry, I need both. That was one. I need both.
Okay.
We have a little weird pattern. That's actually interesting. I don't know why it's doing that.
I think it does.
Yeah. But yeah, so
that's so cool.
Nothing particularly fancy. You've seen this in plenty of other software, but the idea is that you could also do this with brushes, and there's no real reason you couldn't do that with a brush.
You could also do that for like the paper texture you're drawing on, potentially, if we at some point make a more evolved brush system.
Yes.
You could also design the paper you're drawing on, because that also has those bumps.
The reason we're seeing it look all weird is because we're blending the darkest pixel in, because that's how we do the overlap when there's a brush stroke.
Oh, okay. Yeah, so I guess like this like funky artifacting almost.
Yeah, because we're picking the darkest pixel, not the closest pixel.
Yeah. All right. Well, I think we got to end it here just because of time, but this was super cool to go into. And I mean, I'll say it again. I want to see more blog posts, because I want to see stuff about this, not just at the meetups, but also in other places too. So anyways, thank you so much for showing this all off, Kevin and Oliver and Dennis. And hopefully we'll see you next month.
Thank you.
Thanks.
All right. So we are back now at the end of today's meetup. That's it for today. We're going to move over to the Discord if you want to come chat with some of the speakers. And as always, I mean, I normally do announcements here, so I'm like not used to not doing announcements. I'll remind everybody again, we got the Rusty Jam coming up next week, and so pretty excited for this one. Newsletter is out. One sec, I don't know if there's anything like I should show off in here in particular. Go read it. Newsletter is great, a lot of fun, lots of cool stuff in there. All right. Anyways, thank you everybody for coming out, and we will see you next month.